Determine the domain and range of the function. I have this graph up here still. It was used in the previous example, and it will help us determine domain and range for this rational function. Now, a domain is a set of all valid inputs. And in this case, the only invalid input is this vertical asymptote here, which is x equals -1. And for the range, we have all outputs except this horizontal asymptote, which is y equals 2. And those can also be found from the function here. This x plus 1, you set the denominator equal to 0, and then you solve, and you can't divide by 0. So you get x plus 1 equals 0. So x equals -1 is your vertical asymptote. And this plus 2, this is the horizontal asymptote here. So it's just y equals 2. So what happens is eventually, because you're dividing by x, the denominator gets really large and approaches 0 when x gets really large, either in the positive or negative direction. So really, this part doesn't matter so much, the -1 divided by x plus 1, and the only part that really counts is this 2, because this other number gets so small. And that's why it approaches 2 for the y. So now you have an idea about the domain and range, but let's see how you write it in set builder notation. The domain, x is an element of the real numbers, such that x is not equal to -1. Okay, so that means x is essentially all values except -1. Now for the range, y is an element of the real numbers such that y is not equal to 2. All right, so there's our domain and range in set builder notation.